You might have heard some people claim that the Earth is flat and that there is no evidence for its roundness. But that's not true. There are many ways to prove that the Earth is round, both with simple observations and with sophisticated experiments. And the reason why the Earth is round has to do with some fundamental laws of physics. Hello and welcome to Curiosity, where we explore fascinating topics from history, science, culture and more. Today we are going to answer a question that might seem obvious but is actually quite challenging. Why is the Earth round? And what is the proof? Let's start with the reason why the Earth is round. The answer lies in two things: mass and gravity. Every single thing in the universe has mass, from the biggest star to a tiny grain of sand. People also have mass. And mass attracts mass. This attraction is called gravity. The more mass something has, the stronger its gravity. The Earth has a lot of mass, about 6 trillion kilograms. That's a lot of zeros. And because it has so much mass, it has a lot of gravity. This gravity pulls everything on the Earth towards its center. It also pulls all the bits and pieces that make up the Earth together into a compact shape. But why a round shape? Why not a cube or a pyramid or a donut? Well, imagine you have a pile of snow and you start to squeeze it with your hands. What shape will it form? A sphere, right? That's because a sphere is the most efficient way to pack together many small particles with equal pressure from all sides. The same thing happens with the Earth. Gravity squeezes all the rocks and metals and liquids and gases that make up the Earth into a spherical shape. But not all parts of the Earth are equally squeezable. Some are more rigid and some are more fluid. And some parts are moving, spinning and shifting due to other forces. One of these forces is called centrifugal force. It's the force that makes you feel pushed to the side when you're on a merry-go-round or a roller coaster. The Earth is also spinning around its axis, which creates centrifugal force at the equator. This force counteracts gravity and makes the Earth bulge out at the equator ever so slightly. It's a very small effect due to the Earth's fairly rigid structure combined with its slow rotation. Another force that affects the shape of the Earth is called tidal force. It's the force that causes the tides in the oceans due to the gravitational pull of the Moon and the Sun. The tidal force also stretches and squishes the Earth along its axis, making it even more flattened at the poles. There are also other factors that influence the shape of the Earth, such as plate tectonics, volcanoes, earthquakes, erosion, glaciers, and human activities. All these factors cause local variations in elevation and density that make the surface of the Earth uneven and bumpy. But despite all these variations, the Earth is still very round on average. How do we know that? Well, there are many ways to prove that the Earth is round, such as observing its shadow on the Moon during a lunar eclipse. The shadow is always circular, which can only happen if the Earth is spherical. Seeing different stars in different hemispheres. For example, Orion is upside down if you're in Australia compared to if you're in Canada. Circumnavigating the globe by ship or plane. You can start from any point and go in any direction and eventually come back to where you started without changing direction. Measuring its curvature with instruments or satellites. You can use a level or a plumb line or a laser to measure how much the horizon drops over a certain distance. Looking at photos taken from space. You can see for yourself that the Earth is round from images taken by astronauts or satellites. The roundness of the Earth is not only a scientific fact, but also a beautiful phenomenon that reflects how nature balances different forces and processes to create harmony and stability. The Earth is our home and our planet, and we should appreciate its beauty and complexity. That's all for today's episode. Thank you for watching Curiosity. If you enjoyed this video, please like and subscribe for more content like this. And don't forget to share your thoughts and questions in the comments below. Until next time, stay curious.